Okay, in this little clip, what we're being asked to do is graph a piecewise defined function, and once we're all done, figure out when it's continuous and when it's not continuous. So what I did was I went over to Desmos, and you can see that I have each of the little pieces here. I want to explain what they're there for and what they do. So I'm going to go turn on the first piece, and you can see it's the line minus 3x minus 6, but not the whole line. It's just the piece we want. How did I do that? Well, right next to the function, I put the whole function in parentheses. In braces, I write down the condition x is less than minus 1, and we get exactly the piece of line that we want. And piecewise defined function, that's a good thing. All right, so I'm going to shut that off. I'm going to go turn on the second part. I'm supposed to graph the function 3 cosine pi x, but not the whole thing, just the piece that's between minus 1 and 1. Now, how did I get a less than or equal to's? All you have to do that, you just type in a less than symbol and then an equals. In the right spot, unfortunately. Less than equals x. There we go. And we get exactly the piece of function we want. Turn the piece off. Go to the next piece, turn it back on. And what you're going to see here is actually, I wanted a piece of parabola, and we just went over polynomials. So I thought, hey, I'll put that in there. So this is a parabola, but it is a degree 2 polynomial that goes through 1, it goes through 3, it opens up. I only want the piece between 1 and 4, so that's exactly what I got. And finally, I got 12 over x, which, by the way, is a power function. That's x to the minus 1. We actually know what that looks like. And we just got just the piece we wanted. And I want to turn all the pieces on. Turn all the pieces on. And we get the entire function. It's a little dishonest because I can't look at 1 and actually see if the point is down here or up here. So I want to add one more point. Now, what point do I want to add? Let's see here. I want it to be in the green parabola. Actually, I just want to add the point 1, 0 so I can see it. So I'm going to put the point 1, 0 right there. I don't like that it's solid, so I'm going to go over here. I'm going to click and hold, and I can actually make it be a hole. No, I liked it solid. Yeah, no, solid's good. I don't know what I was thinking. Yeah, that's better. Yeah, like that better. Okay, hey, we have our whole function graphed. Remember, this is one function. So the function looks like a line, and then stops looking like a line. It looks like a piece of trig. Stops being a piece of trig, turns into a polynomial. Stops being a polynomial, turns into a power function with a negative exponent. Now, finally, after we were all done, we were supposed to look at this and say when the function isn't continuous. Well, the function isn't continuous at the places where you have to lift up your pen. So I'm going do-de 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 do. I stop right there. I have to pick up my pencil, go back up here, plot that dot, do-de 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 do, do-de 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 do. So the only place it's not continuous is x equals 1, and I'm going to add that as a little note so we can just read it, writing right here. This function is continuous everywhere except at x equals 1. And we're all done.